All right, let's check out method 2 for solving the same problem as before. That is finding the sum and product of a given quadratic equation. So same process, given the general form of a quadratic equation, which is ax squared plus bx plus c equals 0, then we know that the roots of the quadratic is x equals alpha and or x equals beta. That is, x can become alpha or beta as the solution of this quadratic. However, if we recall from the factorization method, there's a way I can project this thing back inside to get back the actual expression. So from here, I can write this as x minus alpha, because if alpha comes inside, it becomes negative, then nothing will be here and it becomes 0. Same or similarly for this becomes x minus beta equals 0. Now I can bring the two of them together and becomes x minus alpha and x minus beta equals 0. Now let's asterisk this expression over here. Then we can recall also from the completing the square method. We can recall from completing the square method, that's ax squared plus bx plus c equals 0. The first step we take while using completing the square method is to divide all through by the coefficient of x squared, which is a. So we can say this is ax squared over a plus bx over a plus c over a equals 0 over a. Now if you divide all through, you'll notice this will nullify this, and 0 over any number is 0. So this can be written as x squared plus b over ax plus c over a equals 0. Now this, I will call it equation 1. Equation 1. Just keep it over here. Then let's go back to the previous asterisk expression. Let's do something. Now, going back to the previous asterisk expression, let me rewrite it here. I'll write it as x minus alpha and x minus beta equals 0, the asterisk expression. Now let's open this asterisk expression. By opening and multiplying this with this, then I'll multiply it with this, then I do the same with this and with this. That is x multiplied by x, I'll get x squared. X multiplied by this, I'll get minus beta x. Then I'm done with that. Now alpha times this will give me minus alpha x. Then minus times minus is plus, alpha times beta. So the last one, which is alpha multiplied by beta, is alpha beta equals 0. And if you notice from these two expressions, there's a common value or common expression, which is x. So we can write this as x squared minus open bracket alpha plus beta into x plus alpha beta equals 0. There's no big deal there. If you open this expression back, you will get everything in this expression. Now let's try it. Now let's rewrite this. I will have x squared is not necessary, just for comprehension. So x squared, then minus, open my bracket. Now let me use this to multiply everything inside first before I use my minus to open the bracket. So x multiplied by this, I will have alpha x plus x multiplied by beta, I will have beta x, and close the bracket, plus alpha beta. Now equals 0. Now I want to open the bracket with my minus. I will have x squared minus alpha x minus alpha x, minus times plus will also give us minus beta x plus alpha beta equals 0. You can see that this and this are the same. The only difference is alpha x is coming first, which the order doesn't matter, but it's the same process. So we can continue from here. Now to continue from here, all we have to do is to compare this. But before we compare this, let me label this as equation 2. We will compare equation 1 and equation 2. Equation 1 and equation 2. Just write by comparing equation 1 and 2. Let me write equation 1 here. X squared plus b over ax plus c over a equal, you equate them together so you can compare them, equal x squared minus alpha plus beta x plus alpha beta. No need to put equal to 0. Both of them are both equal to 0. So there is no need for that. Now we know if we compare this and this, the coefficient of s squared and s squared is 1. So it's more or less insignificant. So let's work on the x expression and the constant expression. So to work on this, I know that b over ax is equal to minus alpha plus beta x. Now if you remember, when they talk about sum is alpha plus beta. So in order to make this alpha plus beta stand alone, first we have to nullify these two, because this two is already signifying that they are both from the same expression by comparing them. So we'll be left with just b over a equals minus alpha plus beta. Now we divide both sides by minus 1, by minus 1. At the end of the day, this will nullify this. Then my alpha plus beta will just be minus b over a, minus b over a. So it means by the second method, by factorizing, we will still get the same expression, that is alpha plus beta will be minus b over a. Now let's see for the second one, which is the last term here. Just compare both of them. You see alpha beta is equal to c over a, which is exactly the same expression we got when we use the other method. We use the other method because sum was alpha plus beta, which is equal to minus b over a, and alpha beta is c over a. Thank you. And remember, mathematics is the word, and the word is mathematical.